Welcome everyone. We're going to do lesson 6 in chapter 11 and it's called radical expression. So remember, a radical is like a square root symbol. Our objective is you'll be able to simplify radical expressions and identify and graph exponential functions. Actually, that one we're not doing right now, so we're going to cross that off. But our language objective is we'll be able to define what a radical expression is and what a radican is. So let's get started. Well, a radical expression is a term or a monomial that has a radical sign, this little symbol right here, in it. So as long as we see a radical sign in the expression, it's a radical expression. And all of these have radical signs in them. Now, what is a radicand? A radicand is the quantity or the expression under the radical sign. So my highlighter is not the best, but everything I highlighted with this yellow, these are the radicands, okay? Because they're underneath the radical sign. Notice that the 4 is not a radican because it's not underneath, and the 5 is not because it's on the outside. Oh, I forgot to highlight this. Whoops. We'll highlight that right there. It must have disappeared. Okay, so what we're going to learn in this video is something called simplifying, or to simplify a radical expression. And in order to simplify it, what we do is we remove all the perfect square factors from the radican. Here's what I want you to do is when you do these assignments, keep a list of all the perfect square factors. For example, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. So what would be next? 16. Then we have 25, 36, 49, 64, 81, and then 100. So this list is very important because here's what we're going to do. Now, if I were to say, well, what's the square root of 9? You'd say the square root of 9 is 3. Okay, no problem. The square root of 18. Well, we don't know the square root of 18, but what we're going to do is we're going to look at our list and say, are there any numbers on this list that can divide 18? And the answer is yes, 9 can divide 18. So we're going to, instead of write 18, we're going to say 9 multiplied by 2 is 18. All right? Then each number can have its own radical. And when I do this, I notice that, hey, I can square root 9, and this becomes 3. And then all I need to do is bring down the square root 2 next to it. So if I use a calculator and I were to do the square root of 2, and if I hit multiply by 3, I would get the square root of 18. I would get this. It would turn back into this. So let's do a lot more practice on the next slide. We will do square rooting numbers in the next slide. We're going to jump to what happens when we square root a variable. So we have a variable with a non-zero or even exponent. This is a perfect square, and we're going to square root this x to the 8th. And I want to show you how I want you to approach this. So if we have x to the 8th power, that means there are 8 x's multiplying to each other here. And I want to talk about what square root is. If we were to square root 9, the reason that works is it's really 3 multiplied to itself. So each pair that you can come up with, that means you can say one of those outside. So remember, what multiplied to itself is 9. 3 times 3 is 9. So the square root of 9 we know is 3. Same thing here. If I say, what's the square root of x squared? The square root of x squared is just x. But the reason is, it means that there are 2 x's inside, and you can circle those and then pull one out. That's how we're going to approach this. I'm going to circle my pairs. I have 1, 2, 3, 4. So I have 4 pairs, and that's what this exponent is going to tell me. So the square root of x to the 8th is really x to the 4th, because if I were to multiply that by 2, which is squaring it, it would turn back into 8. So here's my answer. Well, what happens if we have an odd number? Let's look at that. I have 7 x's underneath the radical, so that's my radicand. I'm going to circle my pairs. So 1, 2, 3. So I have x to the third, okay, because those pair up, but what's still left inside? 1x. So I need to write that here. So 3 pairs came out, but 1's inside. Could I check? Sure, I could check. If I were to square this, 2 multiplied to 3 is 6, plus the 1x that I have inside. So it would work. It would work. Let's try it on a couple examples. So let's write this out. So write out 2 x's and 5 y's and circle your pairs and see which ones will come out. Here's what I got. I ended up with 1 pair, because we're counting pairs again, remember. 1 pair of x's and 2 pairs of y's, and then there's 1 y left inside. Okay, let's do the square root of 28x7. First off, I gave them their own radical. So remember the list of our perfect squares? Which of these squares could divide 28? And 4 can divide 28. So what I'm going to do is instead of saying 28, I'm going to say 4 multiplied to 7 is 28. Now, I can square root the 4 and I can square root the 7. When I square root the 4, I end up with 2. I still have this square root of 7. I'll come back for that. Now let's deal with our variable. So I need to write 7 x's right here. Okay, I ended up with 3 pairs of x's. So here's 1 pair, 2, 3. So now they can come out. If you pair up, you can come out. So they come out, and I have x to the third to represent 3 pairs, but there's still 1 x underneath the radical. So it's right here. So in red, I showed the things that could come out, and my final answer is going to be 2x to the third, but then we're going to multiply that to what's still in the radical, okay, our radicands. 7 is in there, and x is in there. So here's my answer. All right, so I said that we had practiced numbers some more. We're going to do it right now. Simplest form of a square root expression is when the following happens. So the radicand has no perfect square factors other than 1. So in other words, none of these numbers here can divide what's inside. The radicand cannot have fractions. We'll talk about that later, but you can't have a fraction in the radicand. And there are no square roots in the denominator, and we'll talk about that. It looks like this. So here, write these examples. You can't have, you can't square root a fraction, and you can't have a square root in the denominator. We'll talk about that later. That'll be a different lesson. So let's break this down. 24. Can any of these numbers divide 24? And the answer is yes, 4. So let's write that. 24 is really 4 multiplied to 6. So we have to square root the 4 and then square root the 6 separately. The square root of 4 is 2, but we cannot square root 6, and none of these numbers will divide it, other than 1, but that won't help. So here's our answer. Let's try this one, 128. Let's figure out which of these numbers can divide 128. I'm going to use this to show you what happens when you divide by one number, but you discover you could have divided by a bigger number. So I know it ends in 28. Because it ends in a multiple of 4, 4 can divide 128. And 4 goes into 12 3 times, and 4 goes into 8 twice. So I know that I can square root the 4. So if I square root the 4 and square root the 32, the square root of the 4 is 2, and I square root 32. Now I look here, can I divide 32 by any of these numbers? And you know what? If I look here, 16 can go into 32. So this is what's going to happen. I'll bring my 2 down, and instead of saying 32, I'll say 16 multiplied to 2. Okay, so now each of these gets their own radical. The square root of 16 is 4. And the square root of 2, we can't do that, so I'll bring it down. Now, I'm going to take the 2 and multiply it to the 4, okay, because they were already outside. So 2 multiplied to 4 is 8. And then my square root of 2, which I'm getting from right here, that just is going to come over with the answer. So there's my answers. So looking back, 64 could have divided into 128, but I didn't know that. So this is how you solve a problem like that. All right, on this problem, before I start, I can add these together. It's like a parenthesis. So what's 40 plus 9? And 40 plus 9 is 49. Now, can I square root 49? Yep, the square root of 49 is 7. So this answer is just 7. All right, on this page we have a lot of examples. If you want to hit pause and do them yourself, you can. Otherwise, you can follow along. All right, so I wrote 3 x's and 4 y's. So now I'm going to count how many partners I have, how many pairs. I have 1 pair of x's and I have 2 pair of y's. And what's left inside is just one little x. So this x comes right here and it's left inside. So here's my answer. All right, so here's what we end up with. On this one, if you want, you can hit pause and try and do it yourself. All right, notice I wrote 3 x's and 2 y's, and I have 1 pair of x's and 1 pair of y's. I just talked to Miss Senny, and there's 1 x left in the radical. Miss Senny tells the kids that this is jail. And if you want to get out of jail, you have to partner up to get out of jail. So you partner up to get out of jail. And if you don't have a partner, you stay in jail. And when you come out, you only need one of then she says your partner dies once you get out. That's not very good. But when you get out, you only need one of them to represent you. So you can think of it that way. Let's do this one. So square root the 48 separately and then break these apart. All right, so 48 can be divided by 16 on my square list. So 16 multiplied to 3 is 48. So the square root of 16, that's 4, but I still have the square root of 3. The 3 is still trapped in jail. Here I can take a pair of these a's up and take one out. So now I have an a, and I have the b is still in jail, no partner. So now let's put these together. So the outside numbers would be 4a, but still in the radical, the radicans would be 3 and b. Those stay inside. What happens when we have a fraction? Well, first say to yourself, can you simplify this? Can I reduce 2/50ths? And the answer is yes. That's 1 over 25. Now, what I want you to do is give the top number a square root, and give the bottom number a square root. What's the square root of 1? 1 times 1 is 1. So the square root of 1 is 1, and the square root of 25 is 5. So that's how I got my answer. Let's try this one. First, I'm going to divide 256 by 4, and when I do that, I get 64. Well, now all I have to do is the square root of 64 is 8. Done. Here, I have 5/4. I cannot reduce it, but what I can do is give the top number a square root and the bottom number a square root. And I see that the bottom number, the square root of 4, is 2, but I cannot square root 5. And that's okay, because if you remember the rules said you can't have a fraction in the radicand, and we don't now. It also said the denominator you can't have a square root here. But you know what? I don't anymore. So my answer is square root of 5 over 2. So it's okay to have a square root in the numerator. All right, 4 more examples. So let's look at 12/27 and let's try and reduce that. Okay, I end up with 4/9 because I divided them both by 3. Now, each one gets their own square root. So the top gets a square root and the bottom. So the square root of 4 is 2, and the square root of 9 is 3. So this answer is going to be 2/3. All right, let's look at this next problem. I'm going to reduce this first. Remember, exponents, I can minus this m from here and end up with m to the second. Okay, so I subtracted over 9. Now, let's square root the top. Okay, square root the top, and then square root the bottom. I have one pair to get out of jail, so I get m on top, and then down here the square root of 9 is 3. I'm done. Let's do this one. On this one, I'm going to write out my y's. And now instead of writing the square root of 4 here, I'm going to show you why this method up here works. We know that 4 is really 2 multiplied to 2. So I'm going to circle my pairs. I have 1, 2, 3 pairs of y's. So I'm going to write y to the third because I had 3 pairs. Let's look down here. I have 1 pair of 2's, so I'm going to write 1, 2 here. And remember, what's the square root of 4? The square root of 4 is 2. So it works for numbers just like variables. One question left. Let's try this one. I'm going to use the method I just used again. So instead of saying 9, I'm going to say 3 times 3 is 9. And I'm going to write out 3 x's. And then instead of saying 16, I'll say 4 times 4. So here I go. I have 1 pair of 3's. I have 1 pair of x's. But I still have 1 x left inside, so I need to show that this x is still in jail. Here I have 1 pair of 4's, so I'm going to write that here. Let's look. The square root of 16 is 4. The square root of 9 is 3. Looks like it worked. Here's my answer. Here are the practice problems. Don't feel, I would like you to write out 6 p's and 4 x's and circle your pairs and get them out of jail. If there's an odd amount, one guy stays in jail. So do your practice problems and bring any questions you have to class next time we meet. Take care.